Fireproof insulation is a critical material used in various applications, including space stations, boats, airplanes, cars, and even household appliances. Its ability to withstand high temperatures and provide excellent insulation properties makes it an essential component in many industries. In this guide, we will explore two different methods to create fireproof insulation. The first method is a complex scientific process that requires specialized equipment and materials. The second method is a simpler, home-based approach that anyone can try using everyday ingredients. Before we dive into the details, it's essential to understand the importance of safety. Both methods involve heating substances to high temperatures and handling potentially hazardous materials. Always follow safety guidelines, wear appropriate protective gear, and work in a well-ventilated area. Method 1 is a scientific approach to creating fireproof insulation. This method is based on the synthesis of 3D graphene, a material known for its outstanding insulation properties. The process involves heating glucose and ammonium salts under controlled conditions to create a foam-like product called SG, sugar-blowing graphene. Materials needed: 10 grams of glucose, 10 grams of ammonium salts, NH4Cl, tube furnace, 50 centimeters length by 5 centimeters diameter, protective gear, gloves, goggles, lab coat, argon gas as an atmosphere around the liquid. Procedure: preparation of materials. Mix 10 grams of glucose with 10 grams of ammonium salts. Ensure that the materials are thoroughly combined. Heating process: place the mixture in a tube furnace and heat it under a desired heating rate. 4 degrees Celsius -1 is recommended. The furnace should be set at 1350 degrees Celsius for 3 hours under an AR atmosphere. Observation: during the heating process, the mixture will transform into a black foam-like product known as SG. Characterization: the resulting SG can be analyzed using various techniques such as scanning electron microscopy, high-resolution transmission electron microscopy, atomic force microscopy, and optical microscopy to understand its structure and properties. Application: SG can be used in various applications, including supercapacitors, supports, catalysts, sorbents, hydrogen reservoirs, gas sensors, air filters, sound absorbers, and more. Detailed explanation: understanding the process. The sugar-blowing approach synthesizes 3D graphene, made of graphitic membranes tightly connected and supported by robust graphitic microstruts. The process involves complex chemical reactions and requires careful control of temperature and heating rates. Potential challenges: this method requires specialized equipment and knowledge in chemistry. It may not be suitable for home-based experiments. Always consult with a professional or work under supervised laboratory conditions. Safety precautions: handle the materials with care, as they can be hazardous at high temperatures. Wear appropriate protective gear and follow all safety guidelines. Method 2: home-based approach to creating fireproof insulation. This method is a simpler approach to creating fireproof insulation using common household ingredients. It involves heating sugar, water, and nitric acid to create a carbon foam with excellent insulating properties. Materials needed: 500 grams of sugar, 500 milliliters of water, 8 milliliters of nitric acid, stove oven, silicone container, and a kiln is optional. Preparation: add the sugar to the water and heat it up on your stove. Stir continuously to dissolve the sugar completely. Creating the syrup: add the nitric acid to the sugar-water mixture to create a syrup. Continue stirring to ensure even mixing. Pouring: pour the syrup into a silicone container. Silicone is recommended as the mixture sticks quite firmly, and it can withstand high temperatures. Baking: place the container in the oven at 120 degrees centigrade for 2 days. You will notice the mixture bubbling and caramelizing, frothing up like a brick foam. The foam will turn a brownish color. Carbonizing: leave the container at the same temperature for the next day and a half. The foam will gradually turn black as it carbonizes. Final baking: increase the temperature to 220 degrees centigrade and leave it for a further 16 hours. You'll end up with a solid lump of bubbled up carbon foam. Optional kiln process. If you want to create a reticulated foam, where all the cells are open, you can put it in a kiln for 3 hours at 600 degrees centigrade. However, this step is optional. The carbon foam can be used to insulate rocket stoves, ensuring a full burn and super efficient performance. It can withstand high temperatures, making it suitable for applications where intense heat is involved. Understanding the process, this method involves a series of heating and cooling processes that transform sugar, water, and nitric acid into a carbon foam with incredible insulating properties. Potential challenges, timing and temperature control are crucial in this method. Any deviation from the specified temperatures or durations may result in a product with different properties. Safety precautions. Handle the hot syrup and carbon foam with care. Wear heat-resistant gloves and eye protection. Ensure proper ventilation, as heating these materials may release fumes. Applications and benefits. This carbon foam is recognized as an outstanding insulation material. Its lightweight, mechanical strength, and off-the-chart insulation properties make it suitable for various applications, from household insulation to aerospace technology. Creating fireproof insulation is a fascinating process that can be approached in different ways. Whether you are a scientist working in a laboratory or a DIY enthusiast looking to experiment at home, understanding the principles, procedures, and safety precautions is essential. These two methods offer a glimpse into the world of material science and the incredible potential of fireproof insulation. By following the detailed instructions provided, you can explore the exciting possibilities of creating this vital material on your own. Remember, safety comes first. Always follow guidelines and consult with professionals if needed. Happy experimenting!